In the previous video, we learned how to consume promises as consumers. We discovered that there are two approaches, one that relies on callbacks and another that uses async await, which is essentially a trick where JavaScript translates what we write into something else, making our code much more readable. One of the things we saw is that asynchronous functions essentially finish at the point where they hit the first await. This raises the question, what if I want to synchronize my code with the completion of the entire function, not just the first part? In other words, how can I know when the second half of the function is done and respond to that? Before we can do all of this with async await, let's go back to the core of promises and see how it's done with the promise methods, then, catch, and finally. What we're going to see today is that then is not just a consumer of a promise, it's also a producer. We'll see that then actually creates a new promise. The technique we're learning in this video is often called either promise chaining or promise composition. Both terms refer to the same idea. To demonstrate this, instead of showing you JavaScript code like I usually do, I'll show you TypeScript code. As you can see, the code is the same, but when I use my editor with TypeScript files, it provides type information through IntelliSense and tooltips, which helps me understand the types of values that we're working with and returned by the methods that we call. Up until now, we treated the then function as if it were a void function. We called it and didn't really care what it returned. But what I want to show you now is that then actually returns something interesting. So let's take P1, which is the promise we used before, the one that resolves after 3 seconds with the value 42. And when we call then on P1, we'll store the result in P2 and see what P2 is. When we look at it, we see that P2 is also a promise. In our case, it's promise of void. So what then returns is called the composed promise. A promise is an object that describes when something completes and with what result. So our composed promise describes when the callback completes and its results. Of course, because the callback only begins after P1 or the original promise completes, the composed promise now marks the completion of both the original promise and the continuation. Because the callback we passed into then doesn't return anything, we get a promise of void. It just logs something to the console. If our callback were to return a value, then P2 would be a promise of that value's type. So you can think of P2 as a slightly smarter promise than P1. It represents the completion of the first promise plus the additional logic we added in the callback. Okay, now, but what if we wanted our callback to do something asynchronous in the continuation? In that case, we'd have another promise. For example, here we have a function called getDelayedString, which returns a promise that resolves to a string after 2 seconds. If we call this function in the then callback, then our callback will return a promise of a string. Now, we saw before that when the callback returned a number, the then method created a promise of number. And when it returned a string, then created a promise of string. You might think that if the callback returns a promise, we'd end up with a promise of promise. But then is smart enough to flatten that out for us, so we still get a flat promise at the end. The same principle applies to catch and finally. Catch also returns a promise, and it can return a value or another promise, which will determine the type of the final promise. But with catch, it may not be clear at first sight what exactly is the value that the promise returns. We'll get to that in a minute. Finally, we have finally, which is a transparent operator. It also returns a promise, but the final promise reflects exactly what happened with the original promise, regardless of what we do inside the finally block. So while its completion is delayed a bit until the continuation is completed, the result of the continuation is ignored and the composed promise returns the same result or error of the original promise. So essentially, the finally method runs a continuation regardless of whether the promise was fulfilled or rejected, but it doesn't change the final outcome of the original promise. Now, let's look at the details in a few diagrams. So in the next 3 diagrams, we'll walk through how the composed promise behaves depending on what happens to the original promise and the continuation. We'll start with then, and then we'll look at catch and finally. So the first diagram is for then. Now, then is a success callback. It describes how to continue when the original promise resolves successfully. So if the result is an error, meaning P1 is rejected, then becomes transparent. It doesn't run the callback at all and simply reflects the rejection of P1. If P1 is resolved, then the continuation runs, and in that case, the result of the composed promise will be identical to the result of the continuation. Catch behaves a little bit differently. Catch kind of expects the original promise to fail. So if it doesn't fail, it simply becomes transparent and resolves with the same result of the original promise. However, if the original indeed fails, it will run the continuation and return whatever the continuation returns. So if the continuation succeeds, catch will effectively turn rejection into success. Otherwise, it rejects with the same error as the continuation. If we look at the TypeScript, we see that the type of promise that catch returns is promise of string or number. That's because the original promise returns a number and the continuation promise returns a string. So if the original promise succeeds, we'll get a number. We'll get that specific number. If the original promise fails, then we'll continue with the continuation promise, and if that will succeed, we'll get its result, which is a string. That means that our successful results may either be numbers or strings. So that's the way catch behaves. The only way catch results in an error is if both the original and the continuation were rejected. And finally, we have finally. Finally is also called the transparent operator. The continuation always runs, no matter whether P1 was resolved or rejected. And the composed promise will only complete after the continuation has completed. But its result is completely ignored, and the composed promise will have the exact same result as the original promise. So you can use it to synchronize something after the cleanup logic has completed, but you cannot receive any value from that continuation logic into the next step. What we've seen in this video is how we can create new promises using then, catch, and finally, and how these methods allow us to chain operations one after the other. The chaining is one of the powerful features of promises, allowing us to represent a sequence of asynchronous operations in a clear and manageable way. In fact, this syntax is called the fluent syntax, where we continue the same statement by chaining one operator after another. Think of then, catch, and finally as operators that take one promise and convert it into another. So as we flow through the chain, the promises we get are more and more sophisticated and contain more and more logic. Now, you might be thinking, wait a second, didn't we say we want to avoid callbacks? Wasn't async await supposed to save us from this mess? Why are we back to chaining then and catch? Well, remember, async await is just a different way to write the exact same thing. Under the hood, it's still using then, catch, and finally. So in the next video, I'll show you how everything we did today looks like when written with async await. See you then.